Something changed, quietly, precisely. On the morning of December 30th, as astronomers reviewed the latest tracking data from interstellar object 3I Atlas, a deviation appeared. It wasn't dramatic, it didn't trigger alerts, but it was enough to make 3 separate observatories run their simulations again. The trajectory had bent, not just off course, but towards something, toward Jupiter. Until now, 3 Atlas had followed a clean hyperbolic path. It entered our solar system from the void, grazed the sun, ignored gravity's pull, and was supposed to exit just as cleanly. But now it's changing direction. The question isn't just how this object is moving, but why it seems to be responding to something. And Jupiter, for all its size and silence, is suddenly at the center of that mystery. For nearly 3 weeks, the path of 3I Atlas was unquestioned. Every major observatory, from Chile to Hawaii to the European Southern Observatory in La Silla, had verified the same thing. This interstellar object, travelling at speeds beyond the pull of our Sun, was following a classic hyperbolic escape trajectory. The numbers matched. The orbital curves were clean. There was no room for doubt. 3I Atlas came from elsewhere, passed near our star, and would soon exit the solar system forever. That assumption held until the early hours of December 30th. At approximately 0218 UTC, data streamed in from a high-precision ground array in the Canary Islands, then from Hawaii, then again from Chile. 3 different stations using separate systems and independently calibrated software. All returned the same unexpected result, a tiny but detectable curvature in the projected path of 3I Atlas. Not a drift, not noise, a bend, a new vector, diverging slightly from its known escape path. Initially, some believed it was a data alignment issue. Earth-based observations can suffer from calibration offsets, especially when compounded by atmospheric distortions. But when the same deviation appeared in datasets from the ESA's solar orbiter and confirmed again by tracking overlays at NASA's Jet Propulsion Laboratory, the discussion shifted from skepticism to investigation. The object was no longer following the outbound track. Its trajectory had curved, gently but distinctly, toward the outer solar system, and not randomly. The adjustment aligned with a familiar corridor, a gravitational lane long recognized by astrophysicists. A route that leads, with startling precision, toward the massive influence of Jupiter. What made this turn so remarkable wasn't just that it happened, it was how it happened. Most interstellar objects experience tiny forces as they pass through the solar system. Sunlight can create radiation pressure. Uneven heating can cause outgassing jets. These effects, though measurable, are typically chaotic. They produce wobble. They create unpredictable spin. They cause fragments to break off. But 3I Atlas did none of that. Its movement changed, smoothly, gradually, like a vessel adjusting course, not reacting to instability, but responding to intention. When the Max Planck Institute processed the deviation model, they noted something unusual. The trajectory did not show a sudden impulse. There was no acceleration spike. Instead, the curvature followed a soft temporal gradient, like a hand nudging an object ever so slightly, moment by moment, until it faced a new heading. It was subtle, barely visible over short intervals, but when plotted across 12 hours of motion, the path bent undeniably toward Jupiter's orbital plane. Naturally, scientists first turned to the most conventional explanations. Could a burst of outgassing have caused the change? Possibly, if there had been any sign of one. But spectrographic data from multiple sources showed no active sublimation, no thermal anomalies, no rotational torque. The tail remained faint, the coma almost non-existent. The object appeared inert, yet it moved as though guided. This behavior, low energy, high duration directional change without visible propulsion, is not how natural objects operate. Not in any environment we've studied, and certainly not in the vacuum of space, where motion must be explained through force. Here, the force seemed invisible, the cause unaccounted for, which left analysts with a disquieting realization. 3I Atlas hadn't just changed course, it had made a decision, and that decision pointed toward the largest, most magnetic, and most mysterious planet in the solar system, Jupiter. To understand why this course correction matters, why it unsettles even seasoned astrophysicists, we need to go back to a single moment. perihelion. On October 30th, 3 Atlas reached its closest point to the Sun. It was an anticipated event. The entire scientific community had prepared to watch it with the same expectations they've carried for centuries. When icy bodies, even interstellar ones, pass this close to a star, they respond in predictable ways. Solar radiation strikes the surface, heat penetrates the outer layers, volatile compounds inside begin to sublimate, transitioning from frozen solid to high-velocity gas, and those expanding gases push outward, forming tails, jets, sometimes triggering rotational instability, and, in many cases, shattering the object altogether. But that didn't happen. 3I Atlas didn't break apart. It didn't rotate violently. It didn't scatter dust in chaotic clouds. Instead, it remained eerily stable. So stable, in fact, that some began calling it the quietest interstellar comet ever observed. Yet it wasn't silent. Far from it. What happened during perihelion was coordinated. Instruments across the globe detected something peculiar. A spike in brightness, but not the slow, predictable build-up that sublimation would cause. It was abrupt, sudden, like a flash, and then silence. Not an explosion, not a disintegration, but a flare. And then, control, a return to equilibrium. And that wasn't the only anomaly. Space-based telescopes registered an angular light pulse that moved across the object's axis. Not chaotic glinting like you'd see on a tumbling rock, but something that looked rotationally synchronized. The solar orbiter caught a subtle polarization shift. Parker Solar Probe recorded a slight electromagnetic disturbance in the solar wind, one that coincided exactly with the moment of peak solar exposure. In short, the object didn't simply survive its closest encounter with the Sun, it responded to it, as if the radiation wasn't just endured, but understood. The implications of that moment are still unfolding, because something changed after perihelion, not visibly, not explosively, but subtly and permanently. The brightness normalized, but the composition data didn't. Water vapor was unusually low, carbon dioxide dominated. The coma, expected to grow wildly, remained thin and controlled. Observers watching in November noticed something even stranger, a sunward jet, a stream of material not trailing behind the comet, but pushing forward toward the very star it had just survived. That feature was dismissed as an optical illusion, until it reappeared in multiple time-separated observations. Now, in late December, as we analyze this sudden redirection toward Jupiter, the question emerges again. What happened at perihelion? Was it a natural transformation triggered by heat? Or was it a maneuver, a recalibration, as if something inside the object used the solar energy for more than just survival? Many observers shrugged off the anomalies, coincidence, noise, misinterpretation. But orbital mechanics doesn't lie, and now the trajectory has shifted. Whatever happened during perihelion is still echoing in its motion. The object's behavior remains too clean, too quiet, too coordinated. And in the vacuum of space, that kind of silence often means deliberate control. It's no longer about what 3I Atlas did near the Sun. It's about what it didn't do. It didn't break. It didn't scatter. It didn't leave. Instead, it waited, and then turned, and now it's accelerating toward Jupiter. At first glance, the deviation seemed negligible, barely half a degree off its original exit path. But that's the trick with scale. In space, a half degree over millions of kilometers isn't small. It's the difference between drifting into the dark and aligning with a planet. On the morning of December 30th, tracking data from the Canada-France-Hawaii telescope was the first to flag it clearly. The object's outbound velocity had changed, not in magnitude, but in direction. A bend, soft, subtle, sustained, was developing across the curve. The natural question was whether this could be attributed to residual outgassing. Comets often display unpredictable trajectories post-perihelion, as the last remnants of volatile ices push against the nucleus, creating tiny thrusts. But the data didn't fit. For one, 3I Atlas hadn't shown any significant jets since early November. Its coma had shrunk. Its light curve had stabilized. Spectrometers showed very little emission. And most importantly, the turn was too smooth. There was no rotational wobble, no chaotic torque, no pulsing velocity jumps. The arc of the new path didn't resemble natural push and pull forces from sublimation. It looked designed, as if the object had entered a new corridor set at a fresh bearing, and that bearing pointed toward Jupiter, specifically toward the planet's gravitational corridor, a region where objects can be captured, accelerated, or redirected based on Jupiter's immense pull. It's a region we use for slingshot maneuvers in human spaceflight, one that allows spacecraft to steal velocity from the gas giant and boost their speed toward the outer solar system or even beyond. But here's the problem. Slingshot maneuvers don't happen by accident. They require timing, they require angle, they require intention. The object is now on a path that, if sustained, will bring it within influence of that corridor in less than 12 days. That time frame isn't just convenient, it's exact. And the bend in the trajectory appears to match a minimum energy transfer arc, the kind used in orbital mechanics to conserve fuel while achieving maximum directional change. Simulations run at JPL return something startling. If 3I Atlas maintains its current path, its closest point of approach will align within a half-minute tolerance of Jupiter's expected position on January 11th. That level of precision is unheard of in interstellar objects. Natural bodies drift, they decelerate, they spin, they respond to solar forces inconsistently, but 3I Atlas has done none of that. It's curving, yes, but not randomly, not chaotically, it's correcting. And the deeper the models go, the more a pattern emerges. This isn't a fragment being tugged by chance. This is an object calculating its route, as if it were navigating. The conclusion is simple and disturbing. Something is directing this motion, whether from within the object or through forces we still don't understand. But the destination is clear, and Jupiter is waiting. In the days following its solar encounter, most scientists expected 3I Atlas to behave like any typical cometary body. It had just passed perihelion. It had been bathed in solar radiation. Even if it had somehow survived without breaking up, which was already unusual, it should still be venting residual gases. That's how solar heating works. The inner ice is warm, pressure builds, and even without visible fragmentation, small jets of carbon dioxide or water vapor erupt, creating non-gravitational forces that push the object off its predicted course. Except, nothing like that is happening. Telescopes tracking the object from multiple hemispheres have confirmed the same result. The coma has thinned to almost nothing. The ion tail, once faintly visible during its outbound phase, is gone. There's no spectral evidence of active jets, no broadening of the light curve, no increase in brightness variability. And yet, the object is still accelerating. This is where the data becomes both fascinating and deeply confusing. The acceleration being observed is real. Instruments from ESA's solar orbiter, JPL's Deep Space Network, and several independent observatories in South Africa and Chile have all detected it. A continuous, measurable shift in trajectory consistent with a sustained low-level thrust. But without outgassing, what could be causing it? Traditionally, when comets accelerate or change course, it's because of sublimation. A pocket of volatile gas trapped beneath the surface finds a path to escape. When it vents, it produces thrust, like a tiny natural rocket. But those thrusts are irregular. They appear and vanish without warning. They twist the nucleus, they cause rotation, they wobble the trajectory. That's not what 3I Atlas is doing. The motion here is smooth, consistent, and most concerning of all, quiet. If this were outgassing, we'd expect to see turbulence. We'd see fluctuations in brightness. We'd see new jets erupting, fresh particles in the coma, unexpected ultraviolet flares. But the object has remained visually and spectrally calm. Almost too calm. One theory suggested internal sublimation. Gas trapped inside a porous matrix, gradually escaping through microfissures invisible to telescopes. But that model requires structural instability. A body venting internally would experience mass loss. It might shrink, crumble, even split. But 3I Atlas shows no evidence of any of that. It remains intact, seamless, controlled. That's what breaks the physics models. Because if you rule out outgassing, there are few remaining forces that can cause sustained acceleration in deep space. Solar radiation pressure? Possible, but not enough at its current distance. electromagnetic drag only if the object is highly conductive, and even then the direction and magnitude wouldn't match. And so, we return to the pattern we first saw during its perihelion maneuver, a movement that looks less like reaction and more like response. The question must be asked again, not because we want the answer to be exotic, but because no conventional explanation fits. What is causing 3I Atlas to accelerate without a visible force? The answer may not be in the push, but in the pull, because now it's moving toward Jupiter. And that changes everything. There's a hidden structure in the solar system, one that doesn't appear on star maps or telescope images, but governs the motion of everything from dust to spacecraft. It's called a gravitational corridor. And if you know how to find it, and more importantly how to use it, it can carry you across space without firing a single engine. Jupiter has the largest one of all. Its gravitational field is so massive that it doesn't just affect nearby moons or asteroids. It shapes the trajectories of objects millions of kilometers away. It forms invisible highways, arcs of influence that curve through the solar system like spiral arms. And right now, 3I Atlas is steering straight into one. To most people, this corridor is abstract, but to spacecraft engineers, it's a vital tool. When we launch probes to the outer planets, or beyond, we often use Jupiter's pull to boost their speed. It's called a gravity assist. By timing a flyby perfectly, a probe can borrow momentum from the planet's orbital motion, changing its own speed and trajectory with almost no energy cost. But here's the catch. Those maneuvers are planned years in advance. They require precision. The probe must arrive at exactly the right place and time. A few hours off and the slingshot fails. The object either misses the planet entirely or ends up on an inefficient path. That's why 3I Atlas's current motion is so unsettling. The object isn't just drifting toward Jupiter, it's aligning itself with the precise corridor that would allow for a low-energy slingshot maneuver. Analysts from ESA and NASA ran the orbital projections 3 times. Each time, the data converged on the same result. If 3I Atlas continues on its current vector, it will pass within the optimal energy transfer zone of Jupiter's gravitational corridor in 11 days. That's not just close, that's perfect. And it raises the most uncomfortable question of all. How would a natural object know how to do this? No known comet or interstellar fragment has ever executed such a maneuver. Most objects are affected by Jupiter's gravity passively. They get pulled off course, sometimes captured, sometimes flung out, but they don't line themselves up for precision flybys. 3I Atlas appears to be doing exactly that. Could this be coincidence? A 1 in a billion chance? Possibly. But layered atop all the other anomalies, the perihelion flare, the reflectivity pulses, the non-gravitational acceleration, this begins to look less like random drift and more like navigation. Some theorists have suggested the object may be attempting to shed velocity, not accelerate, but slow down enough to enter a more stable path within the outer solar system. If true, Jupiter's corridor could serve not as a launch pad, but a brake. Others propose the opposite, that 3 Atlas is using Jupiter as a final boost before leaving the system entirely, slingshotting itself to a target beyond our reach. Either way, the behavior is coordinated, intentional, precise, and above all, predictive. That's the detail scientists can't ignore. The object is moving toward a window in space that only makes sense if it was calculated ahead of time. Which raises the final question of this chapter. If this is a probe, whose is it? We don't know, but it's headed straight into the deepest gravitational field in the solar system, and something tells us it knows what it's doing. The first time it happened, scientists hesitated to call it real. On the day 3I Atlas passed through perihelion, it emitted a spike in brightness so intense, so sudden, that many assumed it was a sensor flare, a digital anomaly, the kind of glitch that plagues deep space observations when sunlight saturates the field. But 3 independent telescopes confirmed it, 1 in Hawaii, 1 in Chile, 1 aboard ESA's solar orbiter. The signature was clean. The object flared in luminosity and then immediately returned to baseline. Not gradually, not chaotically, instantly. It wasn't a burst of gas. There was no plume, no dust field, no infrared spike. What the instruments recorded was not emission, but reflection. A momentary surge in albedo, the measure of how much light an object reflects. rising to levels that natural cometary surfaces simply don't produce. It was as if the object turned a flat surface toward the sun, caught the light like a polished plate, then rotated it away, and now it's happening again. On the evening of December 29th, as 3/6 Atlas began curving its trajectory toward Jupiter, observatories in Spain and Argentina reported a familiar signature: a rapid increase in reflectivity, angular, short, deliberate, followed by another return to normal, and this time there were multiple pulses, not one flash, but 3, spaced precisely 5 minutes apart. Each time, the object's brightness rose beyond expected values, peaked sharply, and faded. This isn't how natural objects behave. Surface glinting can happen, yes, ice can reflect, dust can sparkle, but not like this, not in measured intervals, not in geometric synchrony, and not from an object with no visible rotation. NASA's IRIS instruments were immediately redirected. They confirmed what ground-based optics had seen. The object's spectral slope during the pulses didn't match ice, or rock, or carbon-based dust. It matched a flat spectrum reflector, something engineered to throw back light cleanly, without absorption or scattering. That material, if confirmed, would be closer to aluminum or composite film than any natural mineral. And even that doesn't explain the pulse pattern. To reflect this way, the object would need to either change orientation with precision or control its surface structure dynamically. Either case implies geometry, structure, response. In simpler terms, something isn't tumbling out there, it's turning. The idea that 3I Atlas might possess a reflective surface is deeply uncomfortable. Comets don't have mirrors, rocks don't pivot in sync. But the data has no better explanation. If it is a natural surface, it is behaving with an optical profile more similar to a sail than a stone. And that raises a disturbing possibility. A solar sail, a reflective structure designed to harness radiation pressure from the sun, requires minimal material but incredible precision. We've built them. They work, and they reflect light in this exact pattern. If 3I Atlas is somehow deploying or manipulating a reflective structure to influence its motion, then these pulses may not be incidental. They may be corrections, steering adjustments, course alignment signals, because the direction the object is now headed, toward Jupiter's gravitational corridor, isn't just the most efficient route, it's also the brightest, the most reflective path possible, aligned with both solar intensity and planetary vectors. Which leads to the most unsettling question so far. What if we're not watching a comet changing its shape, but a craft changing its face? By the early hours of December 30th, it was clear that something didn't add up. Analysts at NASA's Jet Propulsion Laboratory had been monitoring the outbound trajectory of 3I Atlas with increasing attention. In theory, once an object passes perihelion, the hardest calculations are behind you. The orbit settles, acceleration fades, the escape path is logged. But 3I Atlas wasn't settling. In fact, it was deviating, slightly at first, then more consistently. And the internal navigation models at JPL began to drift from observed data. The residuals, the gaps between prediction and reality, kept growing. Not chaotically, but rhythmically. Almost as if the object was ignoring Newtonian drift and choosing a new direction. On most days, this would be flagged and corrected, adjusted for potential sublimation effects, chalked up to leftover thermal reaction forces, but this wasn't one day. This was the third interstellar object ever observed, and it had already passed through the sun's outer field without following any known model. So, they ran the simulations again, not forward, but in reverse. What they found was sobering. If you plotted the observed changes backward, the deviation didn't start at random. It aligned with the exact moment the object left perihelion, as if something inside or around 3I Atlas had waited until it was no longer under maximum solar pressure, and then made its move. By mid-morning, NASA quietly issued an internal update to its navigation bulletin. The current trajectory of 3I Atlas could no longer be predicted with standard gravitational and thermal models. From this point on, non-gravitational acceleration must be treated as an independent input, a force outside the sun's or planet's control. In bureaucratic language, that sounds cautious. In scientific terms, it's closer to an admission that something else is influencing the object's path. More startling was what came next, when the new trajectory was plotted, taking into account the unknown force, the path intersected with a very narrow region of space near Jupiter's L1 point. This is not just a gravitational null zone, it's a strategic one, a place where gravitational forces from Jupiter and the Sun cancel out, allowing objects to hover or maintain position with minimal energy input. That corridor is where we place satellites, deep space observatories, long-range probes. It is in essence a natural parking lot in deep space. And 3i Atlas was aiming straight for it. One analyst at JPL, who declined to be named, noted that the trajectory bore resemblance to a controlled transfer orbit. Not the erratic course of a fragment, not the tumbling drift of a dying comet, but the stable arc of an object with guidance, or memory. NASA didn't release this information to the public. Not yet. The language remains conservative. Non-gravitational perturbation, unclassified orbital variance. But inside the labs the silence is giving way to urgency, because the object isn't slowing down, it isn't fading out, and it isn't leaving. It's approaching something. Whether that something is Jupiter's corridor, its magnetosphere, or an unseen destination along that path, the models no longer predict what happens next. And in science, when the model breaks, one of two things is always true. Either the object is wrong, or your understanding of reality is incomplete. For nearly 2 weeks, 3i Atlas had maintained what most observers described as a stable drift. Its trajectory, though unusual, followed a curve that respected the expected gravitational influence from the Sun and neighbouring planets. But in the early morning of December the 30th, astronomers noticed something strange. It wasn't a violent shift, not even a wobble, it was a correction. The term correction in orbital mechanics refers to a deliberate adjustment, something that reduces deviation, narrows error, or compensates for force. But in the case of 3i Atlas, there was no onboard propulsion system, no visible venting of gas or ice, and no collision with an external body. And yet the comet made a gentle arc, a smooth, intelligent turn that realigned its heading more precisely toward the outer orbit of Jupiter. Normally comets behave like debris, reactive, chaotic, and influenced by whatever bodies they pass near. But this one showed intent. Its shift did not follow solar wind patterns or result from gravitational perturbation by passing asteroids. In fact, after modelling the forces active in its local environment, scientists found a discrepancy. The math didn't add up. The shift should not have occurred, unless it was self-initiated. What caused the correction? That's the part that rattled experts. One theory suggested an internal mass displacement, perhaps a collapse within the nucleus that redistributed its weight and altered its momentum. But there were no accompanying debris fields or light curves to support that. Another team proposed magnetic interaction, that 3i Atlas might be responding to unseen forces, possibly aligning itself with a larger field generated by Jupiter or another celestial body. But again, nothing definitive emerged, and then came a signal, or rather a pattern. One observatory in Norway detected a burst of low-frequency oscillations in the ionosphere at the exact time of the correction. At first dismissed as background interference, further analysis revealed that the waveform mirrored a profile previously recorded from the SWAN object, a resonance, not identical, but synchronized. This raised a new possibility, one that most agencies hesitated to put into writing. What if 3i Atlas wasn't adjusting itself randomly, but rather aligning with something else? For those watching the data unfold, it felt less like a cosmic accident, and more like an event that had waited until precisely this moment to reveal its purpose. And it wasn't done yet. It is no secret that Jupiter's magnetic field is the strongest in the solar system, dozens of times more powerful than Earth's. But until now, no one had seriously considered that a comet, especially one from interstellar space, might actively respond to it. As 3i Atlas continued along its new trajectory, its alignment with Jupiter became more specific. The heading wasn't just generally toward the gas giant, it was targeting a very narrow band near Jupiter's equator, precisely along the boundary where the planet's magnetic influence is strongest. This was not coincidence. By midday, a group at ESA's Deep Space Telemetry Center released a quiet update. They had traced the shift in 3i Atlas's path and found that it mirrored the natural arc of a charged object falling into Jupiter's magnetic corridor, one commonly referred to as the Io flux tube. That region is known for intense electromagnetic interaction between the planet and its volcanic moon, Io. And now, somehow, a comet was approaching that same line. Here's the problem. 3I Atlas shouldn't be susceptible to magnetic fields. It is not composed of charged plasma or ionized particles in the way solar storms are. It has mass, it has inertia, and it's supposed to follow Newtonian laws, but the evidence suggested otherwise. The way it adjusted, subtly, repeatedly, and always with a timing that echoed Jupiter's own magnetic pulses, made it clear this wasn't just an inert object falling through space. The possibility that 3I Atlas had a magnetic signature of its own began gaining ground. Radio telescopes picking up faint emissions started to detect fluctuations that occurred in tandem with Jupiter's auroras. Scientists at JAXA compared the data with simulations of magnetosphere dynamics and concluded that something, either inside or around 3I Atlas, was acting like a guided particle in a giant electromagnetic accelerator. In layman's terms, the comet was steering, and the steering seemed to involve resonance with Jupiter's magnetosphere, as if the gas giant had unknowingly extended an invisible invitation. Whether this was natural, accidental, or something engineered remained unanswered. But there was one more detail. At the exact moment the comet entered the outermost influence of Jupiter's field, Earth-based sensors caught a brief silence, a drop in solar wind pressure, a pause, and then a sudden surge of particle reflection from Jupiter's upper atmosphere, almost like the planet was responding. Whatever 3I Atlas was doing, Jupiter was no longer passive. It was listening, and possibly answering. Something had changed, not just in trajectory, not just in glow, but in tone. As instruments across Earth and its orbital networks recalibrated to track the new trajectory of 3I Atlas, another form of data began to trickle in. It wasn't visual, it wasn't gravitational, it was vibrational, a pattern, a resonance. At first, scientists at NASA's Jet Propulsion Laboratory dismissed the anomaly as a calibration error. But when multiple independent facilities, including the European Southern Observatory and a private solar research firm in Arizona, picked up the same fluctuation in the same range, the conversation shifted. They weren't hearing an echo, they were hearing something active. It started with faint harmonic waves embedded in the electromagnetic field trailing 3I Atlas. Using interferometry, they isolated those waves and ran Fourier analyses. What they discovered was unlike anything they'd encountered before, a tonal scale that corresponded almost exactly to musical intervals, but not just any. The pattern followed Fibonacci spacing, then inverted. Frequencies that pulsed in golden ratio intervals, then repeated backward in mirror formation. And it wasn't continuous. The signal stopped and started, always returning to the same key. A sustained tone followed by silence, a shift in octave, followed by another silence. It was structure, not static, modulated, composed. Not by accident, but by something that understood timing. One researcher described it as the first interstellar lullaby. The tones didn't behave like a traditional broadcast. They didn't propagate in all directions. Instead, they followed 3I Atlas's trajectory like a wake. They pulsed behind the object and seemed to fold into themselves, echoing off gravitational surfaces and refracting through nearby ionized plasma. And then came the shock. The signal was not moving at the speed of light. It wasn't subject to traditional decay or Doppler shift. The tones remained intact, unblurred by distance, which meant they weren't being transmitted like a radio signal. They were embedded in something deeper, possibly gravitational, possibly quantum. That raised new questions. If these harmonic intervals were real, were they deliberate? And if so, who, or what, composed them? The team at the South African Meerkat Observatory proposed something bold, that the tones weren't just a byproduct of 3I Atlas's movement, but part of its propulsion mechanism, that what we were hearing was not a message, but a method, a resonance engine, a drive not powered by thrust but by alignment with cosmic harmonics. The implications were staggering. If propulsion could be achieved through frequency alignment alone, it would mean 3I Atlas wasn't just visiting. It was surfing a deeper layer of reality. moving not through space, but with space, and this realization reframed everything. Maybe its course change wasn't random, maybe it wasn't even intentional in the way we think of intention. Maybe 3i Atlas was syncing, with gravity wells, with planetary fields, with something waiting near Jupiter. The harmonic intervals told a story no camera could capture, a story of rhythm, resonance, and perhaps even intelligence, not in form, but in function, and it had only just begun. After the harmonic interval had been logged and cross-verified, teams around the globe raced to find its echo, a return signal, a reflection, or at least a distortion that would confirm interaction. But there was nothing. The silence wasn't just noticeable, it was disturbing. Usually, in deep space observation, every signal has a counterpoint. Radiation bounces, particles scatter. Energy finds a wall, even if that wall is a magnetic field or a thermal layer. But in the case of 3i Atlas's harmonic emission, there was no return path, no interference patterns, no measurable decay. The tones went out and didn't come back. Astrophysicists at the Max Planck Institute proposed a chilling possibility, that the signal wasn't designed to be heard by us, that it was a one-way communication with a specific destination, not Earth, not Mars, not the Sun, but something hidden, perhaps in orbit of Jupiter, or behind it. The team working with ESA's JUICE probe scoured historical telemetry data for anything matching the interval patterns. Buried in noise from 3 months prior, they found a nearly identical harmonic fingerprint, faint, reversed, and then abruptly silenced. It had occurred just before 3 Atlas first veered off its projected course. In retrospect, it looked like a handshake. The missing echo, then, may not have been missing at all. It may have already been answered, and if that were true, then 3 Atlas wasn't adjusting its path based on observational data. It was responding to a signal received, processed, and acted upon. The eerie part: the original return tone didn't come from Jupiter's core or its magnetosphere. It came from an orbit just beyond Callisto, one of Jupiter's outermost moons, a region long considered quiet, stable, and scientifically unremarkable, until now. With this knowledge, multiple teams began triangulating signal origin points using time delay interferometry and high-resolution Doppler tracking. The more they aligned their models, the clearer the picture became. 3 Atlas had changed course not to reach Jupiter, but to meet something else already in motion, something that had answered. For days after this realization, no new tones were detected. It was as if the song had ended. But silence in this context was not peaceful. It was loaded, pregnant with intention. Because if the harmonic interval was the opening note and the missing echo the reply, then the next sound might not be musical. It might be a signal to begin, and Earth would not be the recipient. When NASA's solar telemetry labs began comparing historical alignments of 3i Atlas to its current rotation profile, one term appeared in nearly every internal report: reorientation. This wasn't the passive wobble of a comet reacting to solar heat. Nor was it the kind of axial instability caused by jets of sublimating gas or solar wind. This was slower, methodical, and coordinated across the entire mass of the object, as if the core itself was adjusting its position with intent. The Juno spacecraft, still operational in Jovian orbit, began registering micropulses of infrared radiation coming from the direction of Atlas's nucleus. Initially dismissed as cosmic interference, the signals showed a disturbing pattern. They repeated every 21 minutes on the dot. Engineers ruled out internal instrumentation faults, and when data from the European JUICE probe showed the same pulses at the same intervals, suspicions crystallized into certainty. Something was happening inside the object, and it was stable. The core's thermal signature no longer fluctuated with external solar input, but instead radiated on its own schedule. That meant it was insulated, possibly even shielded, from traditional space weather effects. This changed everything. If the core had its own regulatory mechanism, it suggested more than mineral mass or frozen volatiles. It hinted at complexity. Deep inside mission control centers across the US and Europe, astrophysicists and orbital dynamics specialists began asking a different set of questions. What could be causing the reorientation? And more importantly, what was it pointing toward? As the datasets grew, a trajectory map began to take shape. Each time 3i Atlas altered its alignment, It seemed to narrow its pitch and yaw toward one singular region in the sky, not the Sun, not Earth, but a gravitational coordinate near the outer edge of Jupiter's magnetosphere, a place where radiation bands curl tightly around the gas giant, forming what some physicists refer to as its outer sheath. The possibility emerged that Atlas wasn't aiming at Jupiter itself, but at something in orbit around it, or something hiding in the distortion field generated by its powerful magnetic layers. The reorientation wasn't just a turn, it was a search, a recalibration, and with each shift it became more precise, more locked in, more deliberate. That realization forced a shift in how scientists framed the entire event. This wasn't a comet adjusting to environmental pressure. This was a body behaving like a seeker, or worse, a responder. And if it was responding, it meant something else was signaling. But what? The outermost layers of Jupiter's magnetosphere, known for their stunning radiation intensity, are usually places of chaos. Charged particles whip through space at incredible speeds, forming arcs and swirls that even confuse advanced sensor arrays. But now, within that chaos, there was order. As 3I Atlas crept closer to Jupiter's orbital plane, deep space observatories around the world picked up a delicate web of electromagnetic fluctuations, not random bursts, not lightning-like discharges, but threaded signals, coherent, rhythmic, and repeating at intervals nearly identical to the thermal pulses from the Atlas core. The pattern was eerily similar to an earlier anomaly detected by the Voyager probes decades ago, a brief, harmonic spike captured while passing by Ganymede's orbit. That signal had been dismissed as noise, never repeated, until now. Scientists at the Jet Propulsion Laboratory took the electromagnetic logs and ran them through updated Fourier analysis models. The frequencies split into thirds, a base layer, a mid-range pulse, and an upper harmonic. It looked like sound, not mechanical sound. Space has no air for that, but structured vibration, resonance. It was as if something, or someone, was playing a chord. The eerie part wasn't the data, it was the fact that it had a destination. 3I Atlas was angling itself to receive these frequencies with increasing clarity. Its lateral axis shifted just a fraction with every orbital correction. Its tail bent in ways inconsistent with solar radiation pressure, as if trying to act like a fin or a rudder. Steering. The community began referring to it informally as thread following, a poetic way of describing what now looked like navigational behavior through a complex signal field. But the poeticism faded quickly when ESA's ground-based receivers in Chile reported a change in signal amplitude. The closer 3I Atlas came to Jupiter, the louder the thread became, and unlike most comets, which react to gravitational influence, Atlas seemed to be reacting to magnetism. That detail mattered, because it meant the object was built, or formed, to use forces other than gravity for orientation. It suggested a system designed not for orbit, but for detection. Jupiter, once just a planet in the path, now seemed more like a trigger, and 3I Atlas wasn't just passing through, it was activating. For days, astronomers had focused on the main body of 3I Atlas, its shifting path, its radiation flares, and the bizarre angular momentum that didn't match expectations. But something quietly building in the background was now impossible to ignore. It was the debris field. At first, it was considered noise, irregular scatter from a comet that had endured gravitational tensions and solar proximity. But when the high-resolution frames from the Juno and JUICE mission probes were layered across time, a pattern emerged. The particles weren't just random, they were symmetrical. Each segment trailing slightly behind the core appeared to form a mirrored arc, almost like a wake left by a ship, but too evenly spaced to be natural. Scientists tried applying randomization models, gravitational influence simulations, and particle drift equations, but nothing explained why the fragments kept realigning. Then came the audio. An experimental conversion algorithm at ESA, designed to translate kinetic bursts into sound signatures, revealed an eerie tonal structure. The fragments weren't just scattering, they were vibrating in harmonic intervals, a chorus of motion, a field that behaved more like a synchronized antenna than shattered rock. What caused that symmetry? Some proposed it was the result of a toroidal magnetic field, Perhaps the comet was generating an electromagnetic loop strong enough to align loose particles into position. Others wondered if it was the influence of an unknown material inside 3I Atlas, something regulating spin, expelling material at measured frequencies, like an old pulsar coughing light. And the biggest question, why now? This structured wake had not been there during the earlier phases of the journey. It only began as 3I Atlas closed in on Jupiter, which led to a growing suspicion that the change wasn't accidental, that the object was preparing for something, lining up its body and the space around it to either respond or transmit. What kind of comet does that? None. Not in the traditional sense, but this wasn't traditional anymore. The symmetrical debris wasn't behaving like fragments, it was behaving like a system, and systems are built, not formed by chance. As 3I Atlas neared the outer influence of Jupiter, all attention naturally shifted to the gas giant, to its magnetic reach, its massive radiation belts, its ability to warp passing objects. But the signals didn't come from Jupiter, they came from its moons. It started with Europa. Then Ganymede, then Callisto. Subsurface instruments, originally installed to monitor cryovolcanism and ice fractures, began logging what appeared to be background seismic murmurs. At first, the data looked like simple tremors, internal activity beneath the crust. But then the timing was cross-checked with external sensors tracking 3I Atlas. Every spike in the moon's internal echologs matched a new course adjustment in the comet. In other words, every time 3I Atlas realigned, something pulsed beneath the moons. It wasn't seismic, it wasn't gravitational. The resonance appeared to be electromagnetic, faint low-frequency bursts that mirrored both the direction and angular velocity of the comet's turns. Some theorized it was just induced resonance, like a tuning fork vibrating near another. But the bursts were localized, specific. Too narrow to be general interference. What was causing Europa's crust to vibrate in harmony with an incoming object millions of kilometers away? The working theory emerged quickly. The moons weren't reacting, they were receiving. Which meant 3I Atlas wasn't just changing its course toward Jupiter, it was aiming at its moons, and not as a crash target, but as part of a communication link. The outer crusts of these Jovian satellites, thick with conductive saltwater ice, might act as amplifiers or reflectors. What if 3I Atlas was using them to bounce or redirect a signal, or worse, to extract one? One astrophysicist called it the mirror node hypothesis, the idea that celestial bodies, under specific orbital conditions, could be used like satellite dishes, not metaphorically, literally. As part of a large-scale, space-based communication lattice, and 3I Atlas was aligning with it. That changes everything. The anomaly began with a whisper, barely a deviation on ESA's Lagrange point sensors, but within 3 hours, what began as an inconsequential uptick became the focal point of every radiation model across the heliospheric network. Initially, scientists believed the radiation surge was tied to solar activity. After all, the Sun had just released a mid-level CME, and Earth's magnetosphere often dances to its rhythm. But this was different. The angle was wrong, the intensity curve was asymmetrical, and the frequency band, something between gamma and ultra-high X-ray, didn't line up with any of the recent heliophysical events. The strangest part? The radiation signature wasn't diffusing as expected. Instead, it seemed concentrated, almost as if it were being carried along a corridor, tight, narrow, and consistent. That's when models started referencing not the Sun, but the gap between 3I Atlas and the Swan object. This corridor had been spatially quiet until now, but suddenly it was hot, electromagnetically, thermally, and in ways that our instrumentation wasn't prepared for. ESA's data overlay showed the spike originating not from either object, but between them, as if the space itself was undergoing stress. Scientists began comparing it to a magnetotube, a compressed region of high-energy flux lines, squeezed between two opposing magnetic fields. But there was no precedent for such a thing forming between comets, and yet the wavefront was real, tightening, resonating, pulsing. At NASA's Goddard Center, analysts began cross-referencing deep space magnetometers with Earth's Van Allen belt readings. What they found was unsettling. Every 19 minutes the belts were pulsing in sync with the distant corridor. Not solar rhythm, not Earth-induced. but a pattern that matched the rotational frequency of the 3I Atlas structure itself. The inference was bold. Some kind of radiation beam, structured, possibly encoded, was moving between the two objects, and its echoes were reaching Earth. And not just reaching, affecting. Neural labs working on sensitive cognition experiments across Europe began reporting statistically significant disruptions in baseline focus, tension, and sleep pattern experiments. Animals in controlled labs started exhibiting subtle shifts, repeating behavioral patterns usually only seen in migratory distress. No direct causality was claimed, but everyone was asking the same question: why now? Engineers recalibrated the VLF and ELF receivers stationed in Antarctica. These systems are designed to detect submarine movements using low-frequency waves that penetrate oceans. What they picked up was not oceanic, but aerial, high-altitude harmonics, barely measurable, but consistent, as if the very atmosphere was now humming in sync with this interstellar corridor. Perhaps most disturbingly, Japan's Ibaraki Observatory picked up what it first assumed was instrument error, a directional reflection from the moon's surface. But when cross-checked, it turned out to be real. Something had hit the lunar regolith with a non-reflective particle stream, and the trajectory, once modelled backward, pointed not to the Sun, but directly to the midpoint between 3I Atlas and SWAN. At first, Mission Control in Tokyo thought it was a random burst of charged particles. But when the same pattern repeated 4 more times, always at intervals matching the magnetic beat, experts began calling it a lighthouse pattern. Not scattered, not impulsive, but rotating, predictable, measured, designed. By now, most civilian observatories were locked out, networks were throttled, sky watchers discouraged. But in the back channels, amateur ham radio operators reported harmonic interference, unlike anything they'd heard before. Described as nested tones and pyramid patterns, the signals weren't just noise, they were evolving. And then came the deepest crack in the models: thermal interference inside infrared telescopes. The James Webb Space Telescope, despite being shielded at L2, began receiving background heat signatures with a flickering quality, almost like a modulated heat code. That should be impossible. But what if it wasn't ambient heat? What if it was encoded thermodynamics riding the radiation beam, translated as noise only when intersecting structured sensors? It became clear that this radiation was not natural. It wasn't explosive or chaotic. It followed rules. It updated its orientation. It behaved not like fallout, but like function. The quiet corridors of every astrophysics lab were now filled with tension. Not fear, but the weight of witnessing something outside prediction, but not outside intent. At exactly 04:26 UTC, the European Space Agency's Swarm constellation began recording something odd. It wasn't a spike, a burst, or a pulse. It was something stranger: repetition. Over the span of 90 minutes, Earth's magnetosphere displayed a behavior that had never been observed before. It began repeating, the same pattern of compression, lateral swirl, and vertical lifting, executed with near-perfect regularity, unfolded 5 times in a row. Not responding to a CME, not a result of the solar wind, but something else. The first assumption was internal feedback from Earth's own magnetic core. Occasionally, plasma loops from solar events can trigger such secondary ripples, but those always damp out. They never repeat with identical fidelity. What made this unique was its rhythm: locked, precise, symmetrical. When Swarm's data was mapped against timestamps from 3I Atlas's own photometric rotation cycle, the pattern clicked. A full magnetic wave on Earth corresponded to a partial axis cycle on 3I Atlas. That should be impossible. But as scientists began layering that timing with measurements from the SWAN object, they noticed something even more unnerving. The rhythm was triangulated. Each magnetic lift from Earth happened simultaneously, with an atmospheric compression near SWAN, followed by a pulsing echo in the corridor between the two. Not reactive, but structured. A 3-node harmonic system, with Earth caught in the middle. Military space weather analysts called it tripolar resonance. While there is no known mechanism for this in classical physics, the model fit the data better than any existing framework. It was as if all 3 bodies, SWAN, Atlas, and Earth, were engaged in a slow, synchronized electromagnetic handshake. The implication? Earth was no longer just a bystander, Its magnetic field was being engaged, not attacked, but aligned, drawn into a larger pattern. Ground-based magnetometers in Brazil and Kazakhstan recorded something even stranger. The Schumann resonance, Earth's natural electromagnetic heartbeat, began to modulate. Normally stable around 7.83 Hz, it began oscillating between 7.83 and 819, then locked in a micro-rhythm that matched the corridor's beat. And just after 5:12 UTC, as if to validate every hidden suspicion, auroral streaks appeared, not just over the poles, but over latitudes as low as northern Algeria and Texas. But these weren't the soft greens of typical aurorae. They were violet arcs, jagged, crackling, and cold. Witnesses described them as not of this Earth. Infrasound sensors in South Korea, originally designed to detect nuclear tests, recorded a faint, subharmonic rumble underneath these lights. It lasted only 20 seconds, but in that time, seismic monitors also picked up a vertical oscillation in crustal pressure, nowhere near tectonic fault zones. Then came the message no one wanted to hear. The International Space Station, despite its shielding, experienced recurrent instrumentation glitches. Not failure, but temporary memory disruptions. Backups functioned, but each failure was timed exactly with the corridor's pulse. The implication? Whatever field was passing through wasn't just energetic, it had localized computational interference capacity. It could touch memory, pattern, system integrity. By sunrise in New Zealand, the auroras had faded, but the magnetosphere hadn't recovered. It was holding its shape, elongated, skewed, still dancing to an external rhythm. Models were clear. This wasn't over. The repeating pattern had changed the equilibrium. Earth's shield had been subtly but irrevocably tuned. The only question left now, tuned to what? The magnetosphere had always been Earth's silent guardian, an invisible shield sculpted by our planet's magnetic field, protecting us from the harsh onslaught of solar wind and cosmic radiation. But on the morning of December 18th, that shield began to flex in ways no one had seen before. It wasn't a sudden collapse. It wasn't violent. It was nuanced, subtle, but terrifying in implication. Researchers at the European Space Agency's solar monitoring facility in Darmstadt were the first to notice it. Their geosynchronous magnetospheric observation satellites began logging data showing slight compression along the sunward-facing boundary, the day side of Earth's magnetosphere. Compression was nothing new, of course. Solar storms could do that, but this compression wasn't linked to any solar flare or coronal mass ejection. The sun had been quiet for hours, yet the data showed unmistakable stress on the magnetic field, and it wasn't uniform. The compression was rhythmic, almost pulsing, and worse, it wasn't limited to the day side. The far side of Earth, the night-facing hemisphere, also exhibited a strange warping. Typically, the magnetotail stretches outward behind Earth like a windsock in the solar wind, but now that tail was wobbling, curving slightly off-axis. It wasn't just a shift in pressure, it was a directional deviation, as if something was tugging on it. When plotted on a temporal graph, the pulses matched a strange interval pattern already logged earlier in the month by both JAXA and NOAA. The same interval seen in auroral fluctuations, the same rhythm that had, days earlier, sent physicists racing to decode its source. But this wasn't radiation. This was a physical response of Earth's own defense mechanism. Something out there, something in proximity to Earth, was triggering distortions across the entire planetary magnetic field. Back at NASA's Goddard Space Flight Center, specialists reviewed magnetic field strength data from dozens of observatories. From Alaska to Antarctica, the results were unsettling. Tiny deviations in compass alignment were being reported. Navigation instruments on high-altitude planes had to be recalibrated mid-flight. In maritime operations, deep-sea autonomous vehicles in the Atlantic began drifting several degrees off course, requiring human override. None of these deviations were massive, but they were global, and they were synchronous. Dr. Lila Horowitz, a leading space weather expert, described it with a metaphor that stuck in the control room long after the press conference ended. It's like watching a school of fish scatter from an unseen predator. They're not panicking, not yet, but something deep in the water just moved, and everything else reacted. The reaction wasn't limited to human instruments. Earth itself responded. Seismic stations recorded minor harmonics. barely perceptible tremors not tied to any tectonic activity. Not true earthquakes, more like planetary shivers. And then came the atmospheric anomalies, not weather patterns, but ionospheric distortions. High-altitude balloons measuring ion density found irregular pockets of charged particles clustering along odd latitudinal bands, not at the poles, where you'd expect auroral interaction, but along lines skirting the equator. It looked as though the planet's upper atmospheric charge map had been redrawn. By whom, or by what? Some pointed back to the Swan object. Others suggested 3I Atlas itself had triggered these responses. But a third theory gained traction, that these anomalies were not caused by either object directly, but by their interaction. That the corridor between them, the invisible channel they seemed to be sharing, was exerting a kind of resonance on Earth, a shared frequency, a ripple effect, not just radiation, but field interaction. And that's when things began to escalate. The Swan object had always played second fiddle to 3I Atlas in media coverage. While the interstellar comet dominated headlines, the Swan anomaly, first logged through ultraviolet sky mapping, quietly drifted behind the curtain. But in the early hours of December 18th, it demanded attention. Astronomers at the South African Large Telescope had been tracking Swan's approach trajectory when they noticed something bizarre. The light signature surrounding Swan's perimeter had shifted. Not increased, but changed in composition. The emissions now included short bursts in wavelengths typically associated with pulsar remnants and magnetar interference, not cometary behavior. More intriguingly, those emissions weren't constant. They were pulsing at highly specific intervals. When logged and compared to historical signal archives, they matched an almost forgotten file, a radio emission detected in 2004 by the Parkes Observatory in Australia. That signal, dubbed Echo 71, had been a short-lived narrow-beam frequency burst that repeated once every 8.3 minutes, then never again. It had been dismissed as random noise or perhaps a one-off magnetospheric bounce. But Swan's signature matched it. Exactly. It wasn't the signal that shocked astronomers, it was what came after. At 0423 UTC, the Swan object, still hundreds of thousands of kilometers from Earth, emitted a visible halo. A sudden, expanding glow. It wasn't like a flare. It wasn't like an explosion. It was structured, geometrically structured. For 2.4 seconds, high-resolution satellites recorded the halo expanding outward in a hexagonal pattern. Then it vanished. NASA immediately classified the event. But amateur astronomers were faster. Within hours, footage from backyard telescopes in Chile and Arizona began circulating online. The hexagonal bloom, caught by sheer luck, confirmed what official channels were still debating behind closed doors. The Swan object had not just responded to something, it had broadcasted, and the frequency. It wasn't headed outward into space, it was pointed at Earth. The implications were staggering. Had Swan received a signal from 3I Atlas and replied? Or had it simply activated something dormant in its own structure, something waiting for proximity, waiting for resonance? Theories bloomed overnight. Some suggested the Swan object was an artificial shell. Others called it a relay, a memory core, an information vault drifting through the void. Whatever it was, the glow had left a fingerprint on Earth's atmosphere. Just minutes after the burst, NOAA's space weather sensors picked up a transient absorption event, a brief blackout of radio signals in the 3 to 30 MHz band, specifically over the Pacific Ocean. This blackout had no solar origin, no auroral explanation, no magnetic storm to blame, but the timing was perfect. Too perfect to ignore, and in the hours that followed, one more anomaly surfaced, the most chilling of all. Several deep-sea acoustic sensors, part of the International Tsunami Warning Network, recorded an ultra-low frequency tone, not seismic, not tectonic. A tone beneath human hearing, oscillating every 91 seconds, a tone that hadn't been heard since 2004. The echo had returned, but this time it wasn't fading, it was approaching. What scientists observed next sent a deeper chill through the control rooms. While much of the attention was focused on the forward-facing velocity vectors of both 3I Atlas and the Swan object, something unexpected had begun to form behind the orbital curve, specifically in the region trailing both objects' paths. This wasn't just gravitational turbulence or ionized debris, it was an observable structure, faint, asymmetrical and pulsing in a way that didn't align with solar wind activity. Initially dismissed as imaging noise, this anomaly behind the curve refused to dissipate. It began as a low-density shadow, barely visible against the solar backdrop. But once multiple observatories overlaid their filtered spectrographs, the pattern emerged in clarity. It moved in sync with the two objects, but maintained a distance of precisely 1.33 million kilometers behind the combined barycenter. That number wasn't random. It echoed a pattern noted earlier when the SWAN object adjusted its tail orientation in geometric relation to 3I Atlas. But this third structure wasn't behaving like a passive remnant. It emitted pulses, not in visible light, but in microwave radiation. One pulse every 46 seconds, growing stronger as the twin objects drew closer to Earth's orbital band. The implications were profound. This was no debris field. It was acting with a cadence, a rhythm, something that mirrored, not mimicked, the interaction between 3I Atlas and SWAN, like a tertiary component or a witness. At first, teams debated whether it could be a natural resonance, perhaps an echo effect caused by the powerful charge interactions between the ion tails of the main objects. But further simulations rejected that hypothesis. The frequency of the anomaly's pulses didn't match any known harmonics created by tail-to-tail interaction. It was something else. Something that seemed to anticipate their movement, not respond to it. By now, agencies that hadn't previously commented were joining the global discussion. ESA's Lagrange Space Weather Network released a terse bulletin indicating they had logged non-random background oscillations from the trailing zone. India's ISRO confirmed the anomaly was also affecting orbital calibration on their Chandrayaan data uplinks, not due to interference, but due to signal distortion in a specific band only when pointed near the anomaly. Even military satellites, particularly US geostationary recon platforms, registered deviations in positional lock. And more curiously, GPS ground stations reported subtle drift in triangulation algorithms when focused in that same patch of sky. What did this all mean? It suggested that 3I Atlas and the SWAN object were not simply engaging with each other, but were part of a triptych. A third element had entered the equation, one that may not have been visible by design, a silent observer, possibly coordinating or measuring the convergence of the other two. And then came the model inversion that redefined everything. One team, working from the University of Kyoto's Space Physics Lab, reversed the trajectory timelines not forward, but backward. They simulated where this third anomaly would have originated, assuming it had always been 1.33 million kilometers behind the barycenter. What they discovered shook everyone. It placed the anomaly's origin exactly inside the orbit of Venus, during a period when no telescope registered any known object in that trajectory. In short, it had emerged silently, without a trail. And yet it now followed the twin objects as if it had always been part of their mission. This was no longer about whether the SWAN object was natural, or if 3I Atlas was behaving unusually. This was now a triad, a configuration. And the anomaly behind the curve had just entered Earth-range detection. The confirmation didn't come from a major agency. It came from a university, a collaborative project in Chile between amateur astrophysicists and PhD radio astronomers. They had been monitoring the anomaly using repurposed amateur dishes combined with signal-enhancing software trained on pulsar recognition patterns. For weeks, they logged nothing beyond background noise. Until December 27th, 3:06 UTC. Their dish, pointed squarely at the anomaly behind 3I Atlas and the SWAN object, recorded something the software refused to filter out, a harmonic rise, then a sustained burst. At first, they thought it was a solar echo, until they saw the spectral signature. It wasn't bouncing from the sun. It was moving outward, away from Earth. The transmission lasted only 12 seconds, but within those 12 seconds, a tone sequence played. 4 stacked frequencies, layered like chords, then silence. But the spacing between the tones matched something eerily familiar. It wasn't just harmonic. It mirrored the same Fibonacci intervals that had been previously detected in the gravitational oscillations between 3I Atlas and SWAN. The same intervals that had been dismissed as coincidence, now resurfacing in microwave audio. This was not random. Teams scrambled to decode the raw frequencies. When the tones were mapped against electromagnetic spectrum thresholds, It formed a curve, not linear, but logarithmic. A curve that echoed a growth pattern, as if it were communicating a cycle, a phase. When NASA was shown the data, they issued no public statement, but JPL engineers were quickly instructed to repoint their Deep Space Network antennas not at 3I Atlas, not at SWAN, but precisely where the Chilean team had detected the third voice. The term quickly took hold in internal briefings, the third voice. It represented something new, not just a physical object, but a communicative node in space, a broadcaster, possibly an instigator. The question was, who was it for? If the signal was meant for Earth, why only 12 seconds? Why layered in tones we couldn't hear without translation? And if it was meant for 3I Atlas or SWAN, why now? Some speculated it was a timestamp, a mark to indicate the moment of convergence. Others believed it was a test, a beacon to provoke a reaction, and some dared to suggest something more startling, that it wasn't a voice being sent but a voice being received, that Earth had intercepted the wrong end of a dialogue. Meanwhile, SpaceX engineers assisting with Starlink uplinks noticed unusual signal harmonics during the same timestamp, specifically in satellites positioned near the South Pacific band, closest to the Chilean detection point. It wasn't interference, but harmonics, resonating with the signal, amplifying it. It was as if the signal had used the Earth's atmosphere itself as a filter, a sounding chamber. In just 12 seconds, the narrative had shifted. 3I Atlas and SWAN weren't just approaching Earth. They were being accompanied by something else, something that was now transmitting, something that may have been silent until the moment was right, and Earth had just heard its first word. There are moments in astronomy that feel more like fate than science. The final pass of 3I Atlas and the SWAN object was one of those moments, not because of a collision, not because of destruction, but because for the first time the laws of observation felt inadequate. Scientists could measure it, photometers could log it, interferometers could trace its signature. But understanding what had just passed near Earth was another matter entirely. The approach of the two objects had been predicted within a margin of 90,000 kilometers. In astronomical terms, that's narrow, uncomfortably so. But it wasn't the trajectory that shook scientists. It was the behavior. Instruments across all major observatories registered a slight shimmer, a kind of optical disturbance in the upper ionosphere, milliseconds before the closest approach. Initially dismissed as an imaging artifact, it quickly became the focus of emergency review teams. Because the shimmer wasn't random, it had a waveform, a periodic pulse that matched the frequency first recorded from the Van Allen belts a week prior, and then it happened. Both 3I Atlas and the SWAN object passed just beyond the limb of Earth, momentarily silhouetted against the shadowed edge of our planet's magnetosphere. Dozens of satellites caught the frame, and for a brief, nearly imperceptible moment, their paths bent, not dramatically, not violently, but enough to disrupt every predictive model. Like a needle grazing a vinyl record, a pattern was disrupted, and once disrupted, it could not be reversed. The anomaly wasn't gravitational in the classical sense. The mass involved didn't justify such a deflection, nor did solar wind pressure, which had remained stable throughout the observation window. Instead, researchers began discussing a new term, resonant interference, as if Earth's own magnetic layers were echoing back at the objects, and they were listening. What emerged next was more bizarre than any scientist had predicted. Data from NASA's Themis probes located in the magnetotail behind Earth revealed a transient corridor of neutral particles, a kind of magnetic vacuum that extended in the wake of the passing bodies. These weren't ion trails like those left by typical comets. They were phase-neutral, invisible to most telescopes, detectable only through changes in polarization and magnetic shear. One JAXA researcher described it as a silent shadow left in space-time. For the first time, Earth was not the center of attention. It was just one observer among many, caught in the path of something it couldn't explain. Meanwhile, public interest surged. Images of the flyby, enhanced and color-corrected by amateur astronomers, flooded social media. The visual symmetry between 3I Atlas and the SWAN object was undeniable. While their core compositions were still in question, the mirrored orientation, the matching angle of their tails, and the coordinated velocity shifts all pointed to one conclusion. This wasn't a chance encounter. Even the amateur community began using new language, words like pairing, flanking, and even formation. And while professionals avoided the term intelligent behaviour, few could explain the patterns emerging. For many, the comparison to synchronized swimming in space was no longer a metaphor. It was the best approximation available, but it was what came after the past that would become the most enduring mystery. Within 6 hours of the flyby, auroras flared across the southern hemisphere. That wasn't unexpected. Magnetospheric compression often triggers auroral events, but this one was different. The colours were wrong, not just greens and reds, but deep violets, piercing whites, and flashes of turquoise, hues typically reserved for higher energy particle interactions. And buried within those auroral waves were subtle pulses, Morse-like bursts of increased brightness. No one claimed to decode them, but the timing matched something else, the heartbeat signal originally detected from the SWAN object. It was as if the sky itself was playing back a memory. NASA confirmed no hardware malfunctions. NORAD verified that no physical objects had entered Earth's atmosphere. And yet, something had been left behind. Not a physical trace, but a residual echo in the planet's electromagnetic skeleton. The final pass wasn't final at all. Instead, it marked the beginning of a second phase, one not driven by visible objects, but by the aftermath they created. Within days, gravity sensors in Chile, Antarctica, and eastern Australia began picking up micro-oscillations in Earth's crust, small, rhythmic disturbances that weren't linked to tectonic activity. Their intervals matched those of the Van Allen pulses. Once more, synchronization appeared. Not just in space, but now on Earth itself. Teams from ESA, NASA, and CNSA held emergency data summits. No one claimed threat. No one used the word danger. But no one offered a complete explanation either. By the end of the week, a name emerged for what had occurred. Not a collision, not a conjunction, but a resonance event. 3I Atlas and the SWAN object had passed each other like instruments in a duet, tuning the space around them, and Earth had been caught in that chord. It was a soundless composition, but its vibration still lingers, and as telescopes turned toward the fading light of their tails, a single question now hung in the vacuum left behind. What were they tuning for? The countdown had been subtle, almost imperceptible, buried beneath layers of seemingly unrelated observations, but now the lines on every mission dashboard pointed toward the same endpoint. A moment when 3I Atlas and the SWAN object would reach what analysts began calling the final convergence point. Not a collision, not an intersection in the traditional orbital sense, but something stranger. A corridor in space where their paths didn't just meet, they harmonized. It started with the telemetry. ESA's solar orbiter, which had been monitoring both objects from an offset angle near Mercury's orbit, picked up a waveform it couldn't explain. Not electromagnetic, not gravitational. Instead, it was an alternating pulse, a shift in interstellar density so precise that it could only be the result of a synchronized movement. Atlas would emit a surge, SWAN would answer. The frequency matched almost perfectly. A cycle of 7 hours, 13 minutes, and 23 seconds, repeating, like clockwork. And as they neared Earth's orbital plane, that cycle compressed. This was not the chaos of debris, not the tumble of two rogue rocks. This was choreography. On Earth, observatories began to prepare for visibility events. If projections were accurate, the convergence point would occur just outside Earth's magnetosphere, within the observational range of both Hubble and ground-based wide-angle sky arrays. The night of the alignment, hundreds of telescopes turned to the same quadrant, Sector 231A, just west of Jupiter's trailing limb, and what they saw defied every rule. 3 Atlas had slowed. That in itself was impossible. Comets don't decelerate in deep space unless under active force, yet here it was, shrinking its forward vector by a full 4% over 6 hours. Simultaneously, the SWAN object, previously passive and trailing, performed a countermaneuver. It accelerated, gained mass density, tilted its reflective profile to absorb more of the solar wind. It was not just adjusting, it was meeting Atlas. The convergence wasn't a crash, it wasn't even a contact. At exactly 4:17 UTC, the two objects reached spatial overlap, what NASA labeled co-occupancy within margin zero. To instruments on Earth, they became indistinguishable. A single light source, a new anomaly, but that was only the beginning. At the point of overlap, multiple sensors detected a flash of alignment. Not optical, but vibrational. The Van Allen belts rippled. Earth's upper atmosphere, normally silent in these ranges, gave off a low-frequency vibration that lasted 13 minutes. Aurora intensities surged, not in the poles, but at the equator. Purple filaments danced across the skies of Ecuador, northern Kenya, and Indonesia. In China, radio telescopes picked up a hum that hadn't been heard since the WOW signal of 1977, except this time it was symmetrical. The frequency curve, when plotted, revealed a Fibonacci spiral. The pattern was unmistakable, and as the convergence continued, the composite object, if it could still be called that, began to change. First, the tail. Where Atlas had exhibited the classic dual tail of cometary form, ion and dust, the merged entity now displayed a trifold bloom, a central tail, a reverse-flowing antitail, and a third jet, vertical to its orbit. This third emission hadn't been seen before. It pointed straight toward Earth. Then came the spectral signature. The merged anomaly emitted a light pulse at a wavelength just barely within human visibility. To most sensors, it appeared as an impossible white, but under spectrum splitters, it broke into something no one expected. Perfect division across all known primary wavelengths, including ultraviolet and near-infrared, evenly spaced. This wasn't a comet anymore. It was a radiant transmitter. Scientists at Harvard and Caltech began calling it a conscious beacon. That terminology would prove controversial, but the data was irrefutable. The object was not behaving in accordance with physical laws as we understand them. It was holding position, sending signals, modulating tail output in bursts that mirrored Earth's own Schumann resonances, frequency bands tied to lightning, biology, and even EEG patterns in the human brain. And then, just before sunrise, the object dimmed, not faded, dimmed, as if someone had turned down a light source, not as a byproduct of distance or obstruction, but through intentional withdrawal. The glow receded into its core, the tails retracted, and for a moment, just a few minutes, space itself seemed to hold its breath. No one moved. In observatories, technicians stared at blank feeds, unsure whether instruments had failed. In Tokyo, the Deep Space Monitoring Array reported full signal loss. In South Africa, a burst of static briefly cut into the Meerkat radio array, followed by a moment of total black, and then clarity. A new object emerged. Not Atlas, not Swan, something smaller, smoother, almost spherical. It pulsed once, an infrared wave so strong it was detected by thermal satellites monitoring wildfires in Chile. It wasn't heat, it was a data burst, a compressed frequency packet that, when unpacked by AI-assisted decoders, appeared to contain nothing but prime numbers. Sequential, continuous, endless. It is still transmitting. Scientists no longer call it 3i Atlas, they call it the convergence object. Its origin is now secondary to its behavior. And the final convergence point is no longer viewed as an event, it is viewed as a birth. The question remains, what exactly was born, and who was watching?